This video shows an example of how to answer a probability question when assuming a binomial distribution for multiple draws. So I like to start the question by laying out my conditions first after reading the question. So the machine produces components with an average of 8% faulty rate. So there's two probabilities that I would want to write down, the bad one and the good one. So I'm going to use the letter Q for the faulty probability 8%. On the flip side, I will use the letter P, which is the good one. That would be 1 minus the 8% and equals 92%. So I probably want to write some notes for myself, saying that's the bad one, and this one is the good one. Good. And keep reading the question. If a random sample of 9 components is taken, so that's repeated draws. You take 9 different draws, 9 random draws. Therefore, my n here equals 9. And now it asks you for the probability that there will be fewer than 3 faulty, assuming a binomial distribution. So I'll write down what the question is asking in a simpler way of representation. So probability of less than 3 faulty. That is basically saying, okay, what situations are less than 3? Either there's no faulty, so 0 faulty, or remember we're using the or rule here, so we want to include all scenarios where the condition is met. Okay, so when we use or rule, we are doing plus the probability. Okay, so either everything is good, there's no faulty products, or so add there is exactly 1 faulty product. That's fine too, as long as less than 3, and therefore we have to add the other one as well, probability of exactly 2 faulty products. We wouldn't add a 3 because it says fewer than 3. So if I can find the probability of each of these scenarios and add them together, I will answer my question. For nothing is faulty, everything is good. That means if I have 9 components, let me just type out a possible way of getting the components. That means everything is good. So that actually, let me just move this out of the way because it's for something else. So that's a situation that nothing is faulty. That's a situation everything is good. So if I have 9 products, there will be G, 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 G. Okay, that's the situation where nothing is faulty. So for that to happen, if the probability of a product being good is 92%, and that happens once, but I want that to happen 9 times, my probability will be significantly less. So it's 92. I'm going to write that 92. Oops, that's a really big rubber. I'm going to write that 92 as 0.92. So it's a bit easier to put in the calculator, 0.92. And then this, I will rewrite it as 0.08. Okay, so if we want all those to be good products, I only have to say that I'm going to multiply all those probabilities. So each of these has to be a 0.92, and when those things all happen at the same time, it's an AND situation. So first one is good, second one is good, third one is good, and so on and so forth. The ninth one is good, and that is 0.92 to the ninth power. Okay, because I have to multiply 0.92 9 times. And there's only one way that everything can be good. It's everything is good. So that's the end of that probability calculation. So probability of one bad product, that means, well, let's look at one scenario of one bad product. This is the one I prepared here earlier. This is one way of getting one bad product, is that your first one is bad and everything else is good. So for that to happen, the chance for that to happen is the first one's probability is 0.08, and I'm going to times 0.92 for all the other ones. So if it's 9 products together, there's 8 of those other ones. So that's 8 products in total, 8 of. Therefore, my probability is 0.08 times 0.92 to the 8th power. But you say, hang on a minute, that's not the only way that you will get one bad product. The bad product doesn't have to be the first one, it could be the second one, third one, fourth one, and it could be any of those 9 products. So for you to get an outcome of one bad product, there are actually 9 different possibilities. So this probability you've just written down, you're saying, is only one way that you can get a bad product. So when this bad, either if it's the first one, second one, third one, or not, you calculate a probability when it's at a different position in this list. That probability is going to be the same, and there's 9 different ways that one bad product can occur among the 9. So that means actually this probability has to multiply by 9 to get me all the different possibilities. Notice the number 9, that is also coming from your combination formula in the binomial distribution coefficient. So NCR, so my N here is 9, and I'm choosing one product to be bad. So if you put that in the calculator, you should get a number 9. Choosing 1 out of 9, there's only 9 ways of choosing that one product to be bad. So similarly, to calculate the probability of 2 bad products, and you can say, okay, suppose I have the first 2 being bad, so BB, and then the rest being good, G, 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 G. Okay? And when I multiply all the probabilities of these happening, I would be doing 0.08 twice, so squared, times 0.92 7 times, so that will be 0.92 to the 7th power. And the list here, the first 2 products being bad, is only one way of this happening. There's many other ways that you could get 2 bad in the middle somewhere out of the list of 9. So here again, we invoke the combination formula. So NCR, here I'm choosing, so out of 9 products, I'm choosing 2 to be bad. If you put that in the calculator, you should get is 36. And therefore I need to multiply this probability by the combination coefficient. Now if you put all of that into the calculator, so probability of 0 bad product, probability of 1 bad product, and probability of 2 bad products, add them all together, then you should get your final answer of probability of less than 3 bad products, and that would equal to 0.97, so about 97% chance.